Hello, everybody. This is Coach Tapman. Today we are going to be talking about an introduction to statics. So, what is statics? Statics is the branch of mechanics that is concerned with the analysis of loads, force, and torque, acting on physical systems that do not experience an acceleration, but rather are in static equilibrium with their environment. So, what is this saying? Well, to simplify it, let's assume that we have a system, and we'll call our system a box. And we have several forces that are acting on that box. Let's say you and your friend Bill and your other friend Susan and your friend George all decide that you're going to push on the box all in different directions. Well, now your box isn't moving. Let's assume your box isn't moving while all of these forces are being applied to it in different directions. If your box is not moving, you can make an assumption. You can use a set of equations that comes with a static assumption, and that is that the sum of the forces equals out to 0 in the x and the y direction, and the sum of the moments, the sum of any rotation, is equal to 0 about any point along your system. And so we know there's no movement and there's no rotation within our reference frame, and so it's not moving. So we can make these assumptions. Now we have a system of equations that we can solve for to find unknowns. And so let's look at an example. You have some balance, and you have three masses hanging on your balance, and you have different distances from your fulcrum on this lever. And so you want to figure out the mass of mass 3. You know the masses of mass 1 and of mass 2. And so now, by using a sum of the forces and by summing the moments about point S, you can solve for the mass at mass 3 because your assumption is that the entire system, that your balance is not moving, it's not rotating. And so we can use that to solve for mass 3. So we're going to do that now.
We are going to be solving our example problem now for a static mechanic problem. And so we have our weight balance here. We know that M1 is equal to 50 kilograms and M2 is equal to 75 kilograms. We also know that the acceleration that they are going to be experiencing due to gravity is going to be 9.81 meters per second. But for our intents and purposes, because we don't really want to do math that bad, we're just going to, meters per second squared. We are going to simplify that to 10 meters per second squared. Now we can do some pretty simple math. So, right off the get-go, just because I've done these problems for a while, I'm going to tell you that this is all going to come down to the sum of the moments in the positive direction, as just a way of writing sum of the moments in the positive direction, is equal to 0. And so how can we start solving for that? Well, we know that our fulcrum here's our fulcrum. We're going to treat this as our reference point, and we are going to solve for the moments due to these three different masses. We already know our radiuses for them. The only unknown bit of information here is our mass 3, and we'll be able to solve for that. So, if we draw on force vectors here for all of these weights, we know that they're all going to be pulling downward. In our scenario, we'll call that the negative y direction. And so we know that if about S, if M3 is going to cause a clockwise rotation about S due to the radius times the force, if it's going to be clockwise, we know that that is going to be considered negative, whereas M1 and M2 are going to be creating a positive or counterclockwise rotation about S. They will be positive, so we can set them equal to each other. So what we need is M1 times 30 centimeters plus 40 centimeters And we know because they're perpendicular that that is going to be equivalent to the moment or the torque, m1 times 30 plus 40 plus m2 times 40 centimeters is going to be equal to m3 times 30 centimeters. And again, we know this because if our balance is not rotating about our point S, then any of the negative rotation coming from mass 3 must be equal to the sum of the positive rotation due to mass 1 and mass 2. Those are equal because we are not moving. It all starts with right here, our static assumption that it's not moving. There's no acceleration. So, just get rid of some of those drawings really quick. We can start solving by adding more values. So for starters, I'll go ahead and make this 0.7 meters times 50 kilograms plus 0.4 meters times 75 kilograms is going to be equal to 0.3 meters times mass 3. Now we're going to start plugging in some of those values, and we're going to solve for M3. So we get that 0.7 times 50. We know that 0.7 meters times 50 kilograms is going to be equal to 35 meters times kilograms plus 0.4 times 75 is going to be equal to 30 meters times kilograms. And that is all going to be equal to 0.3 times M3 meters times kilograms. And guys, I apologize, I forgot to state earlier, but we can assume that the acceleration on all of these objects due to gravity is going to be equal to 0. So really when we're solving our sum of the moments, what we want is our radius times our force is equal to our radius times our force. What we've done here is we've just simplified that further to say our radius times our mass times our acceleration, because our mass times acceleration is our force. And we've just canceled out the acceleration. We don't need to account for it because it's equal on both sides. So from here, now we're able to solve for 65 meters times kilogram is equal to 0.3 times M3 meters times kilograms. And we are going to get that our M3 value is equal to 216.7 cancel all that out. 216.7. And we had already applied our kilograms over here, but just for simplicity's sake. And so we're able to solve for the value of that mass of M3 just using the sum of the moments. And so from the get-go, just being able to assume that there's no rotation occurring because the sum of the moments is equal to 0, we're able to set up this equation, we're able to set the positive and negative rotation equal to one another, and we're able to solve for the full value of the mass for M3. So thank you guys so much for watching. As always, if you have any questions or comments, please leave them below. I would love to get back to you as soon as possible, especially if there's something that I can help you understand. So thank you so much.